Have you been hearing about how computer vision is going to revolutionize apps, development, workflows, and user experiences, but you're not a data scientist and you have no idea how you could actually use it yourself? Have you ever written something down on a piece of paper, only to have to go type that out later to go share it out with someone, or dig through a pile of papers to get back to that note that you had just created? Have you ever been overwhelmed by vast amounts of text data and wish you had an easy way to make sense of it all? Hi, I'm Kyle. I'll later be joined by Michael, Andy, and Heidi. And today we're going to show you how you can use cognitive services to make use of all these different kinds of inputs that are emerging in the modern world. Now, when I talk about input, what do I actually mean? Traditionally, when people think about input, they think about things like mouse, the keyboard. If you're on a laptop, you have a touchpad. But in the modern world, input has gone well beyond these. There's now touch. There's digital ink. There's voice. There are images or pictures that you're taking on your phone. So trying to think about all these can seem daunting. It's our goal to let you easily use AI to revolutionize your workflows. This will let you embrace any input on any device type, letting your users use the right tool for the job. In addition, we'll show you how you can use this to enhance your business processes to be more efficient than ever before. What's this actually mean, though? Let's take a look at a scenario. So for our scenario, we chose something that most of you have probably had to do at some point, which is filing an insurance claim. Now, we chose this not just because it's a relatable scenario, but also because the core concepts that we're going to show as part of this are things that can apply across a broad set of different kinds of apps. So as you're watching this, try to think about how the ideas that we're showing can be integrated into your apps or your customers' workflows. So we start with our customer, Bob, who is unfortunately having a bit of a bad morning. He got into an accident on the way to work, so he has to go file an insurance claim. He takes a picture of his car using his smartphone, and then using the mobile app from an insurance company, initiates a new insurance claim. Now this photo gets uploaded to the insurance company's back end, where it gets automatically analyzed to determine whether or not the car is totaled or if it's repairable. Now in this case, it's determined that the car is only dented, so it's able to be repaired. And with this, a couple of things are going to happen. First, the case is automatically routed over to a field agent who's going to go out and meet with the customer. Second, it allows the insurance company to get a heads up on what the actual financial impact this claim is going to have on their company. So it allows the financial side of the incident to move along much smoother. So next, the field agent goes out to meet with the customer. They're walking around the car, they're taking notes with the customer, they're taking pictures of the car. Since they're standing around and moving around a whole lot, they're actually using a tablet for this, and they're using their pen to ink their notes on the tablet, because in this sort of scenario, it's a lot easier to go do that than just typing. This also allows them to do things like circle things directly on pictures of the car to highlight damage and things like that, so they have much more contextual notes. Now, these handwritten notes are then automatically recognized using ink recognition, and the text from those notes is added to the case details. Now, the text that was recognized is then automatically analyzed along with other pieces of related text content from this case. Things like emails between the customer and the insurance agency, maybe additional typed notes that the agent had done back at their desk, or maybe even scanned documents, say, from a repair shop. These are all analyzed together to automatically extract key case details, as well as put together a timeline of the whole incident. And this allows the insurance agent to move this customer's claim along very quickly. In addition, things like the emails from the customer or transcriptions of their calls with the insurance company are automatically analyzed to determine customer sentiment. This allows the insurance company to ensure that their customers are having good interactions with the insurance company or proactively spot issues where they might want to come in and take some corrective action. So in this example, you saw how images, digital ink, and text are all being used as input throughout the customer's journey. And it was only through a use of various cognitive services that the input from all of these can be truly understood to help provide to allow the insurance company to give their users a great experience at the end of the day. So for the rest of the talk, we're going to go deeper into each of these services to show you how you can make use of them in your apps as well. So to start, Michael is going to show you how custom vision can be used to determine if the car was totaled.
Super. Thank you very much, Kyle. Kyle brought up some excellent questions in the first part of our talk here. One of the questions that I think about sometimes is how do we, as developers, take full advantage of all the best in machine learning and computer vision without having to enroll in an 18 to 24-month graduate degree program? My name is Michael Acosta, and I am Microsoft's Western Hemisphere Data Sales Lead. In my job, I deal with a lot of data. And because data is the oxygen for AI, I get to see a lot of AI as well. I think a person could argue that AI, at its core, is really the systematic application of technology to find the hidden relationships between dependent variables, the D's on this slide, and independent variables, the I's. Where do we see correlation or causation between things such that we can identify and predict one thing based on the presence or absence of one or more other things? Well, if we buy that particular definition of what AI is in general, it's easy to see what the magic is of the custom vision service. You only provide two things to the custom vision service: images and descriptions for those images in the form of tags. When you upload your images to the custom vision service, it uses deep learning to find and analyze the visual features within your images. These visual features become the independent variables in our model. This is really where the magic is, because you don't have to set up your own deep learning framework. You don't have to invest in the infrastructure and the expertise to set up one of your own. You can simply use ours. You don't have to invest the time to understand the computer vision space in depth, learning how to quantify facets, angles, color, light, shading, reflections. That stuff is hard. We want this to be easy. After the magic of the custom vision service identifying the features in your images is done, then it uses the tags that you have associated with those images to become the dependent variables in this particular model. You then train this custom vision model, and it will do what all good AI does. It will find the relationships between the independent variables, your image features, and the dependent variables, the descriptions or the tags that you've used. It knows what makes a dent, and what makes a total loss, based on nothing more than the visual features in the images themselves. So when you provide a brand new image to that model, an image that it hasn't seen before, it can tell you whether or not that's a dent or a total loss based on nothing more than the visual images that it's received. So now that we've kind of looked at this at a high level, let's take a look at what a real working model looks like, as well as the code that it takes to implement that. All right, I'm here at the customvision.ai portal, and you'll see that we've got two models in here right now, Car Damage Assessment and Car Damage Assessment Limited. What makes the limited model limited is the fact that we've only given the custom vision service 5 images of dents and 5 images of total losses to learn from. Okay, so let's go into this, and you'll see that we can filter our images by those tags. We can look at the 5 examples of dents that we've provided. We can also take a look at the 5 examples of the total losses that we have given to the model. Now, we can test this model very quickly against an image that's not been part of its training set. So I'm going to hit the quick test button. I'm going to browse for local files, and we're going to test car2.jpg here. When I zoom in, I think we can all see that this really is just a dent. And interestingly enough, the custom vision service predicted that correctly, but notice, it doesn't have the highest level of confidence in its assessment that this is just a dent. Not surprising, given that we only gave the model 5 examples of dents and 5 examples of total losses. So this is a neat trick, but I don't think 41.9% confidence is enough for us to bet an important business process on. But if we are to give the custom vision service just a little bit more data to work with, In this case, we're going to look at the car damage assessment model, the full one. And in this model, we're bringing a whopping 10 images, 10 examples of dents, and 10 examples of total losses to this particular model. An amazing thing happens when we run the same quick test against the same file that we used before. I'm going to browse local files here, and we're going to evaluate car2.jpg. And you can see here now that this version of the model, the custom vision model, can say with a 99.4% level of confidence that this is just a dent. This is the kind of specificity and confidence that you can use to bet your business processes on. Now, you may have noticed here in this web UI that we have the ability to add images. We can upload images into a custom vision model right here. We can associate tags with those images right here. We could train or retrain our model right here. But when you're building an enterprise-grade application like the one that Kyle is talking about at Contoso Insurance, you're not going to use a web UI for that. You're going to want to take full advantage of a robust and easy-to-use set of APIs. So let's take a look now at some of the code that you will use to implement exactly what we've seen here. Okay, one of the first things that you will do when you set up a custom vision project in Azure is you will retrieve the keys associated with that project. There is a training key and there's a prediction key. So the first thing that we're going to do here is we're going to pass our training key to the API so that it knows who we are and what project we're dealing with. This sample application is designed to help make it easy for you to bring images and tags into a model very quickly. So it's designed to look inside of a zip file for images. We're going to take the name of the zip file right here, and we're going to apply that as the name of our custom vision model. Really easy. It is super important that we associate one or more tags with each image that we push up to the custom vision service. This block of code here makes it really easy to do that. Inside the zip file, we have images. Those images were in several different folders when we put them in the zip file. This block of code here is designed so that we can take the names of those folders and automatically create tags in the custom vision service with the names of those folders. Furthermore, it will associate the images with those tags that correspond to its folder name. It's really important that we not create duplicate tags in the custom vision service. We'll use here a simple dictionary object to keep track of the tag names and the tag IDs so that we don't introduce any duplicates. If we were to introduce duplicates, it would throw an exception here, so let's just watch for that. After we have checked to see if we need to create a new tag, then we upload each item in the zip file, making sure to also associate with that image the tag that we either created or retrieved from our dictionary object. Okay, once we've got all of the images and all of the tags pushed up to the service, we can now programmatically train this model. You'll see from this bit of code here that we're going to train this model using all of the defaults. There are some interesting things that you can do with customizing how you train this model, but we're going to stick with all of the defaults here. And once that model is trained, once we have the dependent variables and the independent variables pushed up to the model and it's trained, we are ready now to query that model to make a prediction. And when we want to make a prediction of this model, we need just a couple of things. You might recall just a few minutes ago, I mentioned that we would retrieve two keys associated with our custom vision project in Azure. We would retrieve the training key as well as the prediction key. So the first thing we're going to do here in order to have the custom vision service make a prediction about an image that it's not seen before is we're going to open up communications and pass in that prediction key. We're then going to give a pointer to where that file is that we want to test, and then we're going to wait patiently for the service to return its prediction about that new image in the form of JSON data. Okay, we've seen a lot of the code here. What I want to do is run this sample application live in real time so you get a sense of how it works in the applications that you'll be writing. Okay, gonna hit run. As you may recall, we need to input a training key. I've got a little cheater file here. I noticed that this is a 32-character key, and there's no way I was going to remember it on my own. So we're going to paste, we're going to copy, and we're going to paste our training key in here. The next thing that we want to do is provide that address to where that zip file is. So notice we've got here cardamageassessment.zip. If I go into it, you'll see that we have a folder for dent and a folder for total loss. Each of these folders contains the images that are either dents or total losses. And what you'll see is that when we feed this zip file to this installation routine, it will create the tags, it'll upload the images, and it will associate the right tags with the right images. Now, because it's important to me that you believe that this is a live demo, this is not staged, I'm going to customize the name of this zip file so that it shows up in the customvision.ai portal with that name. Can somebody give me a 4-digit number, please? Anyone? I'm afraid I didn't hear that. 5678. And can you confirm that we've not spoken about that? Okay. Oh, in fact, I mistyped it. Hold on here. I want to make sure it's right. So car damage assessment 5678.zip. Okay, so we're going to feed this installer, this sample code now, this file name, taking care to 5678.zip. Okay, we hit enter, and now what's happening is we have programmatically created a brand new project. You can see that we're uploading each of those files. We've created the tags programmatically, and we're now training this. This should take 15 to 20 seconds to train, again, using all the default options. And I'll use this time to tell you that this is such an economical service. It can cost as little as 0.2 cents per prediction for the custom vision service to render an answer about the images that you've provided it with, the new images that are not part of the training set. If you think about the speed and the cost savings as opposed to having a human go and evaluate that car as to whether or not it's a dent or a total loss, absolutely fantastic power and value here. Okay, the training of this new model is done. We can see, if I come back here to my portal, you will see that we have indeed a brand new custom vision project. Fantastic. What we need to do now is provide a prediction key. And we're going to do that very simply by publishing this brand new model. By publishing the model, we create an endpoint and we make it easy to retrieve our prediction key. So I'm going to grab the prediction key for this newly created model right here. We're going to enter the full path to the image that we want to test. This is the same image that we've been using, car2.jpg. And then we need to retrieve the endpoint URL itself. I can copy that right here. When I hit enter, this is now going to take my local image, programmatically push it up, and we're going to retrieve the response back in the form of JSON data here. You can see, hopefully, I didn't pretty it up here, you can see that with a 99.46% probability, we're dealing with a dent. Okay, hopefully that gives you a sense of how easy it is to leverage this as one of several cognitive services into this business process here. We're kind of focusing on how this can optimize operations for a company like Contoso Insurance, and to carry us through with the next portion of how cognitive services can help with optimizing operations. I'm going to turn it back over to Kyle.
Thanks, Michael. So, back in our demo flow, you saw that there was some digital ink content that was recognized. So this was done through a service called the Ink Recognizer Cognitive Service. As the name implies, it recognizes digital ink content. But it actually does a little more than just recognize the words that are inside the ink content. The first thing that it does is something called ink classification. What this allows the caller to do is pass up to the service a mixed content set of ink. So here, you can see there's some writing and there's some drawings all mixed together. So when the service sees this, it takes a look and understands, oh, a set of strokes here correspond to drawings, another set corresponds to writing. So once the ink has been segmented and classified, then the recognition can occur. For shapes, the service will tell the caller what kind of shape was recognized, in addition to providing points that represent the perfect version of that shape. So if a user tried to draw a square, it's really hard for someone to actually freehand a perfect square. The service understands their intent and will return the 4 points that correspond to a perfect version of that square. So the caller can then either update the ink to be that perfect version of the square or convert it to a specific shape type. The next thing that the service does is with the handwriting content. So more than just telling you what the recognition results were for words, it actually takes a look at the ink content and lets the caller know how all the different ink relates to itself. So this is called layout analysis. And what this does is it will take a look at some strokes and say, hey, these strokes correspond to a single word. This word is part of a line. This line is part of a paragraph. And this paragraph is part of an overall writing region. So this gives the developers a ton of information that they can use at their fingertips for things like converting related groups of ink together in a single shot, or allowing some nice selection experiences where you can just tap and select an entire paragraph at a time. And of course, the service provides handwriting recognition. We recognize writing in 63 different languages and locales. And for each word that we recognize, we both return the top recognition candidate along with the number of alternates that the word may have been in case the user had sloppy handwriting and you want to provide, say, a correction experience for your users inside your app. So how do you actually use it? There are a few pretty easy steps. The first thing that you do is you have to create some digital ink content. And this is a very key concept. We're talking about digital ink here. This is different from a picture of ink because the digital ink is actually comprised of strokes, and each stroke has a series of points that describe the shape of that stroke. So the service uses this information to provide more accurate recognition results for the digital ink content. The next thing that you do is you actually create a request that contains the strokes that you want to go recognize. Now you have a couple options here. On GitHub, we have a series of samples that give you a class called the Ink Recognizer class that makes this trivial to generate, to add strokes to go be recognized. Alternatively, we have a JSON format, which is actually what gets sent up to the service in the back end as the currency between the client and the service. And the JSON format is just a representation of the stroke and point information. So next, you're actually going to go call the service. Again, our samples provide a nice class that you can use with a recognize async method, which invokes the service. Alternatively, if you're doing something custom, you can just invoke the REST APIs yourself. Lastly, you're going to iterate through the response. Now we'll take a deeper look at the response, how that looks in a minute here. But essentially, you get a tree view that corresponds to all the different recognition results. So you can sort of go through it and understand through that layout analysis what's underneath a paragraph, what's in a line, what's in a word. So again, our samples provide you information on how you can go iterate through this, or from the service you get back a JSON file that has that same representation just in a JSON format that you can manually walk through. So let's see what this actually looks like in an app. Give me 1 second here. Switch over. So we know many of you are developing WPF apps. So here I actually have a WPF project in Visual Studio that I'm going to go run. And when I run it, you'll see this is the same app that we showed in our opening scenario that the insurance agent was using to take their notes. So here I've got 2 ink canvases in it, one for the notes, and then one down here for a signature. And I can get beautiful low latency ink being rendered inside there. And there's also a save button. Now when I press the save button, what's actually going to happen is 2 things. One, the ink that's in the note section is being saved, so the next time I run the app, it's going to come up and be present. And the second thing is it's invoking the Ink Recognizer service in the back end to actually recognize the content that was in that note field and save it off to a text file. And that text file is actually right here. So here, you can see the actual recognized text that came out of that notes field. So how is this possible? Let's jump back into Visual Studio. So I'm going to start with showing how I actually added the inking experience into the app. Now, the controls that I use there is something called the XAML ink canvas control. Previously, this was only available to UWP app developers, but through the use of XAML islands, WPF developers can now easily add this into their apps as well. So to do that, first you have to reference the XAML controls. And then in your app markup, all you have to do is add the ink canvas. So here's one for the note canvas, and one down here for the signature canvas. And through those few lines of code, I now have 2 fully functioning ink canvases inside that app. These give you that same beautiful rendered ink at a low latency that you receive through other apps inside Windows. But it's not yet hooked up to do any kind of recognition of the content that's in there. So how do we do that? We're going to jump to the code behind for the actual save button being clicked. So the first thing here is just a helper function where I'm saving off the ink. And that's not super interesting for the purposes of this talk. What is actually invoking the ink recognizer. So the first thing that we have to do is get the ink strokes. So the ink canvas class provides you the ability to just call a simple getStrokes method, which gets all the ink strokes from the canvas and stores them in the object. In this case, it's our note strokes variable. Then you're going to iterate through all the strokes that are contained in there, and you're adding them to the ink recognizer. So this lets the ink recognizer know when you call it to do the recognition what it should be trying to recognize. Next, you're invoking the recognizer through the recognize async method, and this initiates the call to the service. When it comes back, we're going to check and make sure it came back all right. And then we're going to get a handle to the actual root of the tree structure that comes back that contains the different results. And then I have a couple helper functions here that are just iterating through that tree, finding the line objects, taking the recognized text from them, and putting them into a text file. The actual mechanics of doing that aren't as interesting as taking a deeper dive into what the actual request to the service looks like and what the response that you get back looks like. So to do that, I'm going to jump into kind of a debugging app here that allows me to show a little more information about what's actually going on. So here's that same ink that we had inside that WPF app. But now I can actually take a look at what the request up to the service looks like. So we know you're not all going to be using the Windows ink canvas. Maybe you're developing on Android or iOS, on the web, or you're doing your own kind of custom stroke management. So this is showing you what you kind of need from your representation of ink to turn into the JSON format that gets sent up to the service. So all it is a collection of stroke objects, and each of those contain a set of points. So there's a number of strokes here, each corresponding to different parts of the writing. So the next thing we can take a look at is what you actually get back from the service. So again, if you're doing something custom, you're not using our ink recognizer class, this is what the JSON looks like that you get back from the service. Now you're going to get a series of these recognition units, and this is the core thing that you'll be interacting with. Each recognition unit has a category, so you can understand what it is. In this case, the first result is a word. And for words, you'll see the recognized text, which is down here, as well as a number of alternates for what that ink may have been if we didn't get it right the first time. Each object will also return a bounding rectangle information, and will also give you information about what the parent and child of it is. Because like I said, we get this back in a tree structure. So this actually lets you take a look at what that tree structure looks like. So here we have a single root with one writing region underneath it, 3 paragraphs. Each paragraph has a number of lines underneath it, and each line has the individual words that are returned. So this allows you to do some interesting things, like I said before, like a selection experience. So what I can come do now is I'm going to tap on a word. And since we understand what the bounds of that word are, you can go select it. So if you know that word is part of a line, you can say double tap on that word to go select the line. Or you know that line is part of a paragraph. Okay. All right. Okay. So here's another set of ink. And this ink, you can see it has a mixture of writing and drawings. And similar, like in the last example, I can click on, well, okay, I crashed the app. I wrote that, I blame myself. Proving that it's live code. So let me run this again. So here are the results. So I can tap on, again, some writing here and select it. Do the same kind of thing where I can select the whole line or the entire list. But here you can see some of the shape information. So I'll tap on a shape, and I'll just hit that convert button. And there, that's using the points that we returned from the service to make the perfect version of that square. And here, there's a rectangle sort of written at a slant. We can show that as well. And we've got triangles and circles. What's a kind of a real-world application of this mixed content recognition? Well, we have a partner you may have heard of named PowerPoint. So PowerPoint is actually shipping an experience today that allows you to create ink on a slide, select it, recognize it, and convert it. So here's some ink that's on a slide. I'm going to come and select it all. Now, PowerPoint is using the selection from the user to indicate that, hey, the user wants to do something with this ink. So under the covers, they are invoking our service, the ink recognizer service, in the back end. And once the recognition is complete, you get a little flyout. You can click that flyout, and that gives you the options for what you're going to convert. So here in one click, I'm able to convert that entire slide of ink into the PowerPoint objects. So they're using our layout information, our shape information, taking that and allowing you to very easily sketch out a slide and then turn it into some final content. So the next, yes, thank you. So go try this today. If you have an Office 365 subscription, you have access to this. So just go ink on your slide, select it, convert it, have fun. The next thing I want to show you is a bit of a sneak peek. So we know a lot of our developers, you're not only developing for Windows, a lot of you also have, say, a web front end for your apps. But there isn't a great way to actually render ink on the web. So this is a preview of actually a couple things. The first is it's a prototype web inking canvas control that we are creating that sometime in the next year we're planning on making available for folks. But this is to give you the same easy way of creating and rendering ink content on the web that you have inside Windows. So this is actually a website, and these are individual ink canvases here that are also hooked up in the back end to our recognition service. So I can come along here and ink a name. I can ink a phone number. And this is all using our service to do the recognition. And here I'll do a car make. Now an interesting thing about forms is that oftentimes the fields are fairly strongly typed. And we can actually use this information in the service to ensure that we have even more accurate recognition results based on the context of the form. So in this case, we know this first field is a name field. So when we're doing the recognition, we're taking that into account and biasing towards sort of common names that are out there. Similarly, for the phone number, we understand the formats of phone numbers throughout the world, so we're using that to influence the recognition results. Now for the car make field, there's not a car make input scope that's out there and generally used in the public. So one of the things that we're doing here is we're allowing the caller to, when they invoke the service, pass in a set of custom words that will bias the recognizer for that call. So in this case, we fed it a set of common car manufacturers. So when we're doing the ink recognition, we have very contextual results based on what's going on here and what the user is trying to create. So you just saw how you can use the ink recognizer service in the notes scenario, say for that insurance agent. You saw how PowerPoint is using it. And you got a sneak peek here of how this can start coming into play for things like creating forms. Now, I'd like to introduce Heidi from our great partner Wacom, who's going to show you how they are using the service inside their app today.
Thank you. Thank you, Kai. So my name is Heidi Wang. I work for Wacom, and I'm heading the Ink division. In Ink division, we are responsible for software experiences. Thank you. So we are responsible for software experiences, applications, platform, technology, but also partnership. I'm very honored to be here, invited by Microsoft to talk about our partnership, our collaboration around Ink. And we are going to introduce today the new workflow called Ink with Meeting, where we would like to show how we want to realize it with Wacom Ink Space and semantic ink. Before I start, let me give a short introduction to Wacom. Who knows Wacom here? Oh, wow, a lot of people. So a lot of creative people. So we at Wacom, we have been engaged with digital pen and ink input for more than 36 years. And today we are proud to say that every product is really known by the digital artists in the world. So we have helped the whole creative industry to complete the digital transformation. And this is covering automotive, graphic design, game design, animation, photography, and many, many more. So anything that's around creative workflows, we can tell very proudly that our customers knows us. We are also very known in the consumer space. We have been delivering digital pens to many, many products, from PCs to mobile, working together with industry-leading OEMs for more than 3 decades. And Microsoft is our precious partner, really long-term, since the beginning, with a shared belief in digital pen and ink input. And our partnership goes way back to the early 90s. So we found this picture in the archive of our CTO. So at that time, we were together, Wacom and Microsoft, were really believing in the evangelizing of pen computing. So we brought the first pen computer product together. And 2016, we upgraded our partnership within the Universal Pen framework very successfully. We have introduced Bamboo Ink as the very first universal multi-protocol pen that works on almost every Windows Ink device. And this year in 2019, we are going to enhance our partnership on the ink side, where we will utilize Microsoft Cognitive Ink services inside our ink space to take the inking to the next level to create a new flow around ink with meaning. To recap a bit our motivation. So we at Wacom, we believe that pen and ink are the most natural input for human being. It removes all boundaries. There's no constraints for creative thinking, for communication, for collaboration. So every one of us are using pen and ink in our daily lives and for doing many, many things. What we want to do right now is to bring this to the digital, but going beyond the simple digitization. We want to use AI technologies to really simplify workflows, providing additional services to the user and enabling new use cases. WIL is what we call at Wacom as the Universal Ink framework. And we do see digital ink more than just images. So we see it possible to enrich it with metadata and semantic information that really captures the context of the creation of where the user is putting down the content. In addition, we believe that biometrics is really uniquely if we start to capture the context and the process of the creation by capturing the sensoric data of coming from the digital pen. Imagine you can embed this unique biometric profile behind every ink stroke, like your personal signature. Inkspace is our cloud-based application that we have introduced to enable smart note-taking workflows. And in the next upgrade, we are going to give you a preview how we believe that Inkspace, powered by WIL and utilizing Microsoft Ink Recognizer, is able to deliver new workflows. So here you can see notes that I was taking when we were planning our next event, Inkathon. It's being processed right now, and in the back end, we utilize the Microsoft Ink Recognizer and additional recognition of entities from a personal knowledge base. Here you can see all detected entities. A known contact is linked with a simple email action. Additionally, it could offer more actions for different entity types, such as location or adding calendar entries for related events. Both Wacom Experience Center and Inkspace are associated with the right contextual information. Inkathon is recognized as an event. Important facts and action are offered, such as hotel bookings, flight search, or a calendar entry can be added just with one tap. Back to the notes. Let me share a little bit of the technical background. This is my personal knowledge. It is created by 1, the content of own notes that I have taken, and 2, the organization I belong to. So Will Semantic Inc. will link each entity with additional knowledge and then provide related shortcut options. So this Inkspace experience is going to be realized in the course of 2019 together with Microsoft Ink Recognizer. Together with this upgrade on the Ink experience, we will also introduce the next generation of our joint multi-protocol pen called Bamboo Ink Plus. It will incorporate Microsoft's and Wacom's latest pen protocols to really expanding the compatibility of all Windows Ink devices. It will also offer additional experience features like pen tilt and a new, very responsive 10 tip that works very, very naturally on the screen. This is also to be introduced in the course of 2019. At the end, I would like to invite you to join our Inkathon. This is a hackathon for digital ink particularly. It's going to happen in Portland next weekend, so May 17th to 19th, with a large prize pool of $23,000. Together with Microsoft as our gold sponsor, we are going to really engage with the developers, and our expectation is to really create a lot of innovative new ideas around ink application. And even more, Microsoft has committed to include a special prize for the best realization and the most creative idea of $5,000, really by a dedicated sponsorship. So at the end, I would like to really ask you to join us, and please also visit our booth. This is the input and ink booth in the fourth floor, right? Fourth floor, to really grab a flyer and to get more information. So looking forward to see you there. Thank you.
Thanks, Heidi. It's great to see how Wacom is continuing to push the boundaries both in the pen hardware space and also with the experiences that they're adding inside their apps. So please, as Heidi said, for more information about the Inkathon event, swing by the Input and Ink booth. We're in the Microsoft Showcase on the 4th floor. Walk in, go left. We'll have some more information about the event and how you can join. So you just saw how through the Ink Recognizer, you can generate text content from the raw ink that the users had created. Now, to show you how you can actually make use of all of the different text that's coming into your app, I'm going to hand over to Andy.
Thanks, Kyle. Thanks, Kyle. I'm Andy Hickel from the Azure Text Analytics team. You've seen my friends and colleagues talk about some pretty incredible devices and some amazing AI services. Now we're going to take a look at how one more AI service, namely Text Analytics, can be used to pull the knowledge made available by these products to create apps that your customers will love. So we've seen that AI services are getting pretty good at transforming complex inputs into textual data. We saw Ink Recognizer take strokes that were input into our hypothetical app and turn into a blob of text. We saw Custom Vision take a photo of an accident and turn into a structured record that could actually tell the details of the damage done to poor Bob's car. And you can easily imagine that this kind of single accident could be responsible for generating lots of other kinds of text, things like forms, emails, office documents. And so, we're faced with a problem. We've got a lot of text and we need a solution. We need something to be able to help us make sense of it all. And this is where Azure Text Analytics comes in. So Text Analytics is the best way to get started with natural language processing on Azure. We make 4 services available in more than 24 languages. Language detection, which not surprisingly recognizes the language of the languages mentioned in a text. Key phrase extraction and name entity recognition, which help identify and label the most relevant concepts in a doc. And sentiment analysis, which identifies whether the opinions expressed in a text are positive, negative, or neutral. And so today I'm going to show you how to build two different kinds of apps that use text analytics together with other cognitive services like ink recognizer, custom vision, form recognizer, and speech services to make sense of all this textual data that we've collected. All right, so first we're going to start building an app that can turn a pile of text into a timeline that tells us what happened when. And so these kinds of timelines are pretty powerful. They're hard to build, but they're powerful if you can actually build them. And they allow us to summarize content that might be streaming in from different sources. So we're going to look at 3, maybe 4 different sources of information here, namely from ink, from forms, and from plain old unstructured text. And so basically the playbook is relatively straightforward here. We're going to start by converting different kinds of inputs into text. Then we're going to bundle all those inputs up into a payload that can be sent to text analytics. And then we'll run a little Python script that can convert the output to a CSV that orders the key events into a payload, in the payload into a timeline. All right, and so I am going to get set up. So in the interest of time, I'm going to go quickly. But you can actually download all the code that we're going to build on GitHub at Build AI Demos. So both of the demos that I'm going to show you today are actually, there's code available. You can get started and kind of one-click deploy and get ready to go with Azure. So let me switch over. All right. So the easiest way to see the power of cognitive services is through our web-based APIs. And so I'm going to use Postman just to be able to kind of see them in action. And so you imagine I've got there we go. I've got a scan of an email. So this is a screenshot I took that is an email that I sent to our, as part of our putative experiment here about saying that I sold the Ford Fiesta that was involved in the accident to Bob. And this is part of the records that are associated with the claim. And so I can actually take that file, upload it. I've already pre-selected it here, and send it to Computer Vision's read text API. And if I've got connectivity, it'll come back, and you'll see immediately, let's scroll here. You'll see I've presented with a bunch of nasty-looking JSON that provides a series of bounding boxes and a series of text corresponding to the words that are mentioned in that email. And you can see it's actually picking up visual features from the Outlook window as well as the text that's in the body. And it's recognizing arcane names like mine, Andy Hickel, and doing it with relative fidelity. And I can do the same thing for, Kyle showed us how to do that with ink. We can do it with a brand new service called Form Recognizer, which was launched this week. We can actually take a form and load it. And it's the same experience. We upload it, we send a post, and we get the results back in JSON. And so the magic happens when we actually start taking all of this to text analytics. And so I've got 5 kinds of short little documents associated here on the screen. I've got a output of ink. This is the exact output that Kyle showed us a second ago. I've got output from OCR. I've got output from custom vision. I've got output from a form. And I've got output from just plain old variety text. And when I send this to one of our text analytics services, namely entity recognition, we get back a tremendous amount of semantic information about the text. Or we should. All right, here we go. And so we have a lot of JSON. And what we're able to recognize are more than 25 different types of entities. So names of people, places and things, addresses, phone numbers, makes and models of cars. And so what we're able to do, but essentially what we're going to do for this experiment is we're going to actually pull back, we're going to ask text analytics to annotate the text, and then we're going to use that little Python script to be able to pull back sentences that have mentions of dates and keywords associated with them, and that'll allow us to build a CSV. The exciting thing here, and one of the things that sets the text analytics apart, is the fact that we have entity linking. And that allows us to be able to take a concept like the Ford Fiesta or a 2002 Ford Fiesta and map that to a canonical representation. And so we do this with multiple different kinds of canonical object stores. Most notably, if you use the API today, you'll be able to get it available with Wikipedia. And we're working closely with teams internally who have custom knowledge graphs. And so one of my favorite teams that we work with is the Worldwide Learning Innovation Lab, who has a knowledge graph that they've built about all of the cloud products that we make available on Azure and that are available in the marketplace today. And so machine learning can be used to be able to link those concepts to those nodes in those knowledge graph. So in the interest of time, I won't run the Python script just to show you it's a live demo, but I will actually show you the output. And so what we were able to do here is text analytics was able to recognize the dates. We were able to sort that. And then keywords that we added into the payload or into the Python script, we're able to label each of those sentences as either a purchase or an accident or a claim or a repair or the estimated date of the completion of the repair. That's pretty slick, eh? So now we've seen text analytics in action. Let's push it to its limit. So one important input that we didn't look at initially is speech. So Azure Cognitive Services speech services makes it easy to incorporate speech into your apps, no matter whether you're using speech to text to be able to take audio and turn that into ASCII, or speaker recognition to figure out who's talking, or its mind-blowing text-to-speech capabilities to generate natural-sounding speech. And if you haven't seen speech services text-to-speech capabilities, I encourage you to try them. They're absolutely amazing and astounding at how natural they sound. So let's take a look at how speech and text analytics can work together. So imagine, if you will, we've been asked to gather feedback on how well our insurance company call center agents are doing when helping frazzled customers who called in to report a claim. So we're going to want to start, the playbook here is relatively straightforward. Again, we're going to use speech services to turn the audio of calls into text, and then we're going to use two text analytics services, namely key phrase extraction and sentiment analysis, to monitor how satisfied or dissatisfied customers were with the support they were getting. And so if you're new to sentiment analysis, the task here is to be able to categorize whether the opinions expressed in text are either positive, negative, or neutral. And so this requires some nuance in order to figure out that the text in the box in green is uniformly positive, while the text in the box in red isn't quite as good. And this is the kind of hallmark and one of the nice things about using a pre-trained API model like text analytics is that you don't have to worry about all the different ways somebody can say that your service rocks or stinks. We actually do that for you. So in the time I have remaining, I'm going to walk you through how you build a customer feedback analytics pipeline on Azure using Cognitive Services. And remember, all of this is on GitHub, and you can actually come by our booth in Bay E in the Expo Hall and actually see it running with real data. So we'll start with MP3s that need to be uploaded to an Azure storage account. And essentially, the code allows you to build a webhook that triggers a job when new data is uploaded using Azure Functions, pull data from the store, and it runs it through speech to text. And then it runs through sentiment analysis and key phrase extraction. And then one last function essentially properly formats the insights we get from text analytics into a CSV that can be dumped back into the store and displayed using Power BI. And my team built this. It's a reference architecture, and you'll see us add more and more to this as we go forward. So essentially what the beauty and the magic of this and how easy it is to build starts and ends with our SDKs. So here, this is a snapshot of the screen of the speech SDK. And essentially, we're actually just creating a job that pulls the MP3 files in order and then transcribes them asynchronously. That output then is fed into both key sentiment analysis, kind of box at the top here in green, and then the key phrase extraction SDK objects down here in below. The one thing we didn't do was supply the language. So we also do language detection. So if you're only dealing with English language documents, you can hardcode that as a variable. If you want to use our SDK to be able to do language detection, both on the speech side and on the output side, you can do that as well. And then essentially a lot of fancy work here to be able to convert this into a really sexy Power BI. And let's take a look at some of the results here. I will flip over one last time. And so this is data that we took from interaction with a cable company, a TV cable company. And you can see that immediately out of the box, this is no tuning, no tailoring. You can see the people are on these conversations were pretty upset about the cost and the speed of their internet, and it's expensive, and unplugging seems to work and it shouldn't have to, and it's outrageous and stupid. And then on the positive side, they're excited about dragons. There's down here at the bottom, there's 12 people who've talked about dragons, and I can't imagine for the life of me why people would be positive in their cable company with dragons. Maybe Daenerys would know. And what's cool is that you can actually use sentiment to track the tone of the conversation over time and see if you necessarily can take action to be able to intervene in different ways. And so you can see here, 29% in the gray bar on the left, 29% of the conversations were negative, and they stayed negative. But the ones I'm interested in are the ones here with moderate rise or sharply rising, the kind of yellow and black bars, where the customer agent seems to be doing something that sticks. and solving the problem. And the neat thing here is that if you are as interested in information extraction as I am and as my team is, you take a look at those kind of interactions, and we can actually click through to see those. And you look at how name entity recognition or information extraction in general can be used to be able to kind of identify the actions that are being taken, that could be taken to be able to improve those. And yeah, so I will flip back. All right. So today you've seen the power of multiple cognitive services working together to capture inputs of different types and to make sense of them. We've seen how easy it is to build computer vision models. Michael was showed us the difference between a dent and a totaled vehicle, and was able to perform performance at 99%, something better than that humans we could ever imagine to be able to do. We've seen how Ink Recognizer turns digital ink into rich inputs, including text. We've seen Wacom show us incredible kind of the intersection of semantics and digital ink, and kind of caught all of our attention about what the future of these kinds of input methodologies look like. And we've seen a pretty sexy device. And of course, we've seen how text analytics helps make sense of all this natural language. And that's just the beginning. I think one of the things we're really excited about in text analytics and in cognitive services in general are all the emergence of new services that are generating blobs of text that need to be made sense of. So things like personalizer or anomaly detector or form recognizer, services that launched just this week, are all here to help generate sources of text that can be fed into something like text analytics. And so cognitive services, if you remember nothing else, is the best way to be able to use the best that Microsoft has to offer in AI and incorporate that into your apps and services. I'll close by saying that cognitive services may be easy to use, but one thing that's often lost in the conversation is that they're also enterprise ready. Cognitive services have the certifications you need, including FedRAMP, HITRUST, and HIPAA, PCI, ISO, and SOC. They're also available in all of our Azure Hero and Hub regions. That wasn't something that was true a year ago. And they're even available in downloadable containers that can be run anywhere, including on your local machines, in your data centers, on Azure Kubernetes Service, and even on the edge. No other cloud provider can make that claim. Thank you so much for coming to our session. We really appreciate your feedback. We hope there will be a couple minutes here we can take questions, and we're happy to answer if we don't have time up here or at the booth. We'd love if you complete our evaluation at that link. Thank you so much for attending the conference. This is a great interaction for us. But I leave you with a mission. Go build something. Go build something using cognitive services. And so there are links here for Ink Recognizer, Custom Vision, Text Analytics, and Form Recognizer. We're going to be down at 2 booths downstairs, at the Input and Ink booth and the Cognitive Services booth. And we actually have a questionnaire that if you have time or interest, where we're interested in the kind of use cases that you see for different kind of intelligent inputs or text analytics or computer vision. And Cognitive Services is out in force. So if you have any questions about what kinds of talks you should go see, please come up and we'll make some recommendations for you. Thank you so much.